How do map projections distort shape, area, and distance? Imagine trying to peel an orange and flatten the peel without tearing it. That's similar to what cartographers face when they make flat maps from the round Earth. Because the Earth is a sphere, flattening it always causes some kind of distortion. When we create a map, we choose a projection that best fits what we want to show, but each choice comes with trade-offs. Some map projections keep shapes looking correct in small areas, called conformal projections. But when you look at larger regions, the shapes can stretch or squish. For example, countries near the poles might look oddly stretched or distorted compared to their real shape. This happens because the map is trying to keep angles and shapes accurate in small spots but can't do that everywhere. Other projections focus on keeping the size of landmasses correct, called equal area projections. These maps make sure that the land size on the map matches its size on Earth. But to do that, the shapes can get stretched or squashed. For instance, Greenland often looks much larger than Africa on many maps, even though Africa is about 14 times bigger. This is because the map is prioritizing size over shape. Distance is another aspect that gets distorted. Some maps show true distances only from one specific point, like the center of the map. The azimuthal equidistant projection is a good example. It shows accurate distances from the center point, but distances between other places are off. Other maps, like the equirectangular projection, tend to distort distances more generally, making some trips look shorter or longer than they really are. Direction is also affected by map projections. Some maps keep directions correct from one point, which helps with navigation. But when you look at other points, the directions might be off. This is why navigators choose specific projections depending on what they need to do. Because of these distortions, mapmakers pick different projections based on what the map is meant to show. If they want to keep shapes accurate, they might choose a conformal map. If size is more important, they pick an equal area map. For measuring distances or directions, they select projections that best serve those needs. To help students understand these ideas, you can compare different maps of the same area. Show how the size and shape of countries change from one map to another. Using globes and interactive maps makes it easier for students to see why no flat map can perfectly representing the three-dimensional world. They'll learn that every map has its strengths and compromises, and understanding these helps us read maps more carefully. Remember, flattening the Earth always involves some kind of change. Some maps keep shapes correct but change sizes. Others keep sizes right but distort shapes. Distances are only accurate in certain parts of the map, and directions can be off too. Knowing about these distortions helps us better understand what a map is telling us and why different maps are used for different purposes.